Hey, so I wanted to give you a quick intro to Fitts law, which is used in HCI to model pointing tasks. So it was a study in 1954, and it was used to measure how long it took participants to navigate from a starting point to a target that has a certain distance from the starting point and a certain width. And so they use the stylus here to navigate there. And Fitts found that the task time was linear with the index of difficulty, which is a logarithmic function of the distance divided by the target size. And so that means that the further something is away, the longer it takes you. And also, the bigger it is, the easier it will be for you. And this relationship is logarithmic. So if you look on Wikipedia, then you will find this here. So the task time, the average time to complete the movement, nt, is a, which is a constant, depending on the task, plus b, which is a constant, depending on the task and technique that you're using to navigate, times this index of difficulty, which again is this log of the distance divided by the target width. And so that originally was used on a stylus for this 1D experiment because people were only navigating in one direction. But it has been expanded to many domains and many different applications, and it works in multi-scale environments for zooming, for example, as you will see in my paper, as well as in many other applications, as well as real-world applications even. And it's interesting how reliable this relationship has been, even though it's a specific relationship that says that it's logarithmic. And you can often find it, you can often find experiment results like here, where people increase difficulty of some tasks, and then you can see that logarithmically the task times increase with the difficulty. But you can still do interesting experiments. For example, here you see two different groups, and you could imagine that one group has, for example, a touchpad, and one group has a mouse to navigate. And so you can see that like the mouse and the touchpad both have different constants, a and b constants, in this function, which then determine whether or not something is good and easy to use, and that makes it easier and faster to navigate to a target. And so you will see that applied in my paper. And also it's an interesting, I said earlier that it's used in different scenarios, and one of them is also the first step that people made was to go to 2D, where it's kind of the same, except here you have, actually I would say this W is depicted wrong, because I think what matters is the projected width, the width that is orthogonal to the distance. But anyways, more or less it depends on the target size and the distance that you have to travel, and then the time that it takes people to navigate is about logarithmic. And that's the core that is Fitts law. And there's many applications to this which you should learn about more, but that goes beyond what I'm explaining in this video. Hope that's useful.